Very good morning, students. Today we'll discuss from Unit 1 of Machine Learning, that is classification and decision trees. So let's begin. So here today we are going to concentrate on basics about classification and one classification based on decision trees. So let's start with real-time example. So let us take the example as a hipster. So what is a hipster? How exactly we will identify a hipster? So we will have the image like they will have a long beard and they will have a different clothing, etc. Right? So usually a hipster means someone whose fashion choices and music interests fall outside the mainstream, right? So they will usually they will have an alternative lifestyle. So how exactly we are going to identify this hipster apart from normal people? So mostly with the help of facial hair, how far they are having the beard or different hairstyle, we used to identify, right? Um, but facial hair alone not enough for identifying the hipster because they are somewhat similar with hippies, right? So we need to have a proper features to differentiate uh, between this hipster and hippie, right? So we have lot of features. Like as Alsay said earlier, we have different clothing, lifestyle, music interest, beard, mustache, the shoes, habits, all things they will consider. They won't even see in the diagram. You can see the body habit also mentioned. All things, isn't it? So how exactly we'll do the classification? So in this case, we need to identify the difference between hipster and non-hipster. We need to do the start the classification process. The problem of discriminating between different classes of objects, that is called as classification. So find example for which you know the class. Otherwise, we need to take a training set so that that set contain exact classification. Already we know these features mean this belongs to this particular thing. Something like that, we need to take the training set, find a set of features that discriminate between the examples within the class and outside the class. Create a function that given the feature decides the class. So apply the function to new examples. So this is the classification things. And let's see some other example, that is catching tax evasion. So how exactly we can identify it? First we'll take the data from the year 2011, then we will check it for 2012. So this is an old example. You can take it a new one, that is from 2022 to 2023 we can do. So here they are the transaction ID or tax ID, they are giving some serial number. Then refund status is there, yes or no. So that is a boolean function. So refund status. Then again we are talking about marital status. So in marital status maybe single or married and divorced. So these maybe come. Then taxable income and whether in 2011 they cheated or not. So based on that, we will try to classify the data so that we can identify the possibility of cheating in 2012. Okay, so that is catching tax evasion as the example. So here, suppose the refund is no. See, usually refund is yes means literally they refund, they paid, right? So automatically from the table we can say there is a cheat value is 0 if it is refund yes. Am I right? So now the sample element gave is a refund no, marital status married, and taxable income 80K. Whether it is cheated yes or no, we have to identify. So now we need to classify based on the training set. Okay, from the table we can easily identify and taxable income is 80K, right? So automatically based on the table element, we need to identify. So we'll see how exactly we are doing the classification in the later stage. So an instant of the classification problem, that is learn a method for discriminating between record of different classes. So here we have to classify cheaters with non-cheaters. So classification is the task of learning a target function F that maps attribute set X to one of the predefined class labels Y. So one of the attribute is the class attributes, in this case cheat. So two class labels, we are taking yes or no, that is either true or false, something like that. Then here categorical futures, refund and marital status, whereas taxable income as a continuous future. So what exactly we are doing is classification as the task of mapping an input attribute set into a classic label way. Literally, we are mapping to yes or no with the help of attributes, refund, marital status, and taxable income. So the target function is known as the classification model. Descriptive modeling or explanatory tool to distinguish between objects of different classes, understand why people cheat on their taxes and what make a hipster. So these are the two examples we took, but in real world we can take any kind of example and we can do the classification. So predictive modeling, predict a class of a previously unseen record. So see, best examples we can say predicting tumor cells as benign or malignant, classifying credit card transaction as a legitimate one or fraudulent one, categorizing news stories as financial related one, weather related one, entertainment related one, sports, etc. Identifying spam emails, spam web pages, adult content, understanding if a web query has commercial content or not. So classification is everywhere in data science, right? So big data have answers to all the questions. So training set consists of records with known class label, as I said earlier. Training set is used to build a classification model. A label test set of previously unseen data record is used to evaluate the quality of the model. The classification model is applied to new records with unknown class labels. So we'll take the same example, or we can take some different examples. See here, the learning model is given as the input to the learning algorithm, and it will the model it is trained and will give the possible solution. So here we are categorizing based on the attributes values, and the final outcome is yes or no. So the training set already we have a predefined set, that is the classified data. Based on that, we will have a test set, and we will try to get the identify the content. Okay, so now when we are doing this evaluation of classification model, we have to create a confusion matrix. So it count of test records that are correctly or incorrectly predicted by the classification model. So based on that, we are creating this confusion matrix. With this, we have to find the accuracy as well as the error rate. This is the formula that is used for identifying or calculating the accuracy and error rate. Then various classification techniques are there, like decision tree based method, rule based method, memory based reasoning, neural networks, naive bias, and Bayesian belief networks, so SVM, support vector prediction, etc. etc. So today we will concentrate only on the decision tree approach. That is one of the. So let's talk about decision trees. Decision tree means it's a flowchart like tree structure. Internal nodes denote a test on an attribute, whereas branch represent an outcome of the test. Leaf node represents class labels or class distribution. So we'll see one example here. The same tax evasion data set we will take. So here how exactly we are making as a decision tree model here means let us take the refund as a basic attribute, so root node. So refund based on the it has two choices, right? Yes or no. So based on that we will take no. If refund no means automatically there is no need to go further because there is no cheating. So if yes, yes means refund no means we will go for the next attribute, that is marital status. But here we have three categories, right? Married, single, and divorce. But here, according to our convenience, we will take single and divorce as one thing, and married is another one. If there is no married no means if he is a married fellow means automatically there is no cheating according to this this data set. So okay, and if it is single or diverse means then again we are checking the taxable income, and the taxable income we have different criteria, right? So we will take less than 80 and greater than 80k. So based on that we can classify. So whatever training data known fact we are having, based on that we are creating a tree like structure. Now we have another question means what you can do using this decision tree, we can come to a conclusion whether the fellow is cheating the tax or not. Okay, and we can when we create a decision tree, another specialty is we can create more than one tree. So instead of taking refund as a base node, we can take marital status as a base node, and we can create a another tree. So this very different trees we can able to create. So, in conclusion, we can say that tree induction algorithm, which will take the training set as the input data and it will learn, will act as a learn model, and the decision tree model is created. This model is applied to the test data and we will get the possible conclusion. Okay, so suppose there is a question like we have a refund status no, marital status married, and taxable income 18K means whether it is cheated or not. How? So we will just put it in the tree structure or refund yes or no. So they told no. So then we'll go for the marital status married. Married means automatically he is not cheating. So we will get the conclusion that he is not cheating. No. Okay, so this is the way we can apply and we can, so this is explained elaborately and we can possibly, we will identify the outcome. Okay, so this is the example of decision tree classification and this are, that's